Okay, well, today I'm kind of stuck with everything about ionization, the reaction between acid and bases, and they've been like torturing me during classes, just not getting them. So I did some study at home, and here's what I found out basically. Let's start with a fun fact. In the 1880s, a Swedish chemist Svante Arrhenius proposed a theory of ionization to explain the movement of charge in acidic and alkaline solutions. In one experiment, Arrhenius dissolved sulfuric acid into water and found out that the electrical conductivity of the solution increased as the acid was diluted with water. Now, to understand why the electrical conductivity of the solution increased as the acid was diluted with water, we first need to understand how and what is the ionization of acid and water. So let's draw an acid. Let's say it's green, since acid are green. Ha, okay, let's make it thicker. There we go. That's okay. Green. I want it to be. Yeah, there we go. Acid. It's kind of ugly. That's all right. Okay, there we go. And some water. Now let's find blue. Okay, that's our water. Now, when an acid meets water, let's suppose the acid here is sulfuric acid, and let's change the font down to 2017. Yeah, 2017. And the equation for sulfuric acid is H2SO4. Oh, excuse the handwriting. Now, this means water, which is H2O. What we have is H3O. And that happens every time with ionization of acid and water. So when you look at this equation and think about what it becomes of, which is, this is bad. Okay, bad formatting. So you have H3O here. When you look at this comparing to this, um, what's the difference? So there is one more H with H3O, right? Comparing to H2O. But where did the H come from? You may be asking. And this H actually came from the H from H2SO4. Now, when this happens, the H here just comes over here. I make it a H3O because that's what needs to be happened in the ionization of acid and water. So when this happens, the original H2O has gained a proton H from H2SO. This means it is plus 1 because it has gained something. Now, but what happens to the SO4 on the other end here if water has plus 1? Now, similarly, SO will be minus 1. And this is related to our understanding of ionization. Now, to understand ionization, we need to understand ions. Ions are basically just charged ions. They're charged. They have charge. They're plus or minus. So these are all charged ions. There are also different types of ions called cations and anions, but they're too confusing that we won't get into today. And ions are basically what conducts electricity. Now, Now, logically, after the ionization of acid and water, this new water will be more electrically conductive because of the free charged ions inside it, right? And that is true. Let's look at question D of review test 5, question 1. It says the light globe glows brightly when the conductivity of the sulfuric acid solution is measured. When a conductivity kit is placed into 0.10 citric acid solution, the light globe is very dim. Explain this observation with reference to the strength of sulfuric and citric acid. Now, this is a question that is super complicated, involves like so many understanding of strength of acid. So to get in first, we need to understand what strength of acid means. To start, sulfuric acid is the stronger acid out of the two. Now, citric acid is weaker. And the question is, what does the strength of acid mean? It means how partially or completely the acid ionizes with water. Now, this is logical. If an acid ionizes more with water, it means it will have more charged ions. That means its electrical conductivity will be more than the weaker acid that doesn't have as much ions after ionization. Thus, with more charged ions, um, the light globe will glow more brightly with the sulfuric acid ionization process than with the citric acid. And last thing last, we have question E. Explain the difference between the strength and concentration of an acid. This is something that confuses me and have been and still is, but strength basically means the degree of ionization that the acid goes through. So if a acid ionizes completely with water, it will be a stronger acid. If it ionizes only partially with water, then it will be a weak acid like citric acid. On the other hand, concentration is the number of moles of ions in a liter of solution. Now that's just how much number of moles is in the solution. And that's everything we have today. Thank you.